I'm going to go over Convergent geometric series with you today. Before we get started on the warm-up, I'm going to give you a reminder of what our equation is for our geometric series. So to find our partial sums, you're going to have S sub n equals A sub 1 times 1 minus r to the n over 1 minus r. What I'd like for you to do for the warm-up is pause the video now, work through examples 1, 2, and 3, and then come back and compare with mine. Work with a partner if you'd like, and use your calculator. What you need to make sure that you do is that since we don't know if these are geometric or arithmetic series, I want you to identify, is the sequence or series a arithmetic or a geometric using an A or a G, and then find your R or your D corresponding to what they are, and then find the partial sums indicated. So please pause the video now. You're going to see on example 1 is you're going to find that it's geometric with a ratio of 2. I found that by dividing your A2 by your A1, 4 divided by 2, A3 by A2, 8 divided by 4, and so on. If you look through my A through B, you'll find that I used the equation that we reminded ourselves up here to find partial sums of geometrics. So after I plug everything in, I've got a sum for the first 5 to be 62. When n is 50, I got this super large number that went out in scientific notation. And then for C and D, you'll notice that the n's got even larger, and it was an overflow in the calculator, which just means it's too big for the calculator to express. So now let's look on to example 2. Working in this example, we found it to be geometric with a ratio of 1/2. And if you look at A through D, I've plugged in these values into the equation and found that the sum of the first 5 is 31. And then as my n got larger, my values kept approaching 32, because if you look at the ratio is 1/2. So if you think about this, if you raise 1/2 to some power and it just keeps getting larger, what's going to happen is your denominator just keeps getting bigger and bigger while the numerator stays 1, which means that value is going to get closer and closer to 0, making the rest of the equation look the same, which is why that when the n gets larger, the value is just going to continue approaching the same number. And this is what you call an infinite sum. The infinite sum in a geometric series is when, no matter what the n is, it starts approaching the same value. So if you look at number 3, it says, what do you notice about the sums in number 1 and number 2? Number 1, they just keep getting larger, but in number 2, they're all approaching the same value of 32. So now we need to look at, okay, what's going to make that happen? So this can only happen in a geometric, because if you think about it, it's raising a fraction to a power, which means that the only number that's going to get larger is the denominator, making that value actually smaller. So the particular characteristic that has to be present in the series is that your r has to be less than 1. Here's where you need to keep things straight, though. The negative, if you had, like, for example, a negative 1/2, it's still going to do the same thing. So the negative is only going to help you with signs. So therefore, when we look at what has to happen in a series, you take the absolute value of r. If it is less than 1, then you are going to be what's called a converging series, and it's all going to converge to the same value of 32, which is called the infinite sum. So if we look at these first 5 here, this kind of explains what convergent is. When you're given series now, you have to decide, are they arithmetic, are they geometric, and if they are, find their difference or their ratio. And in this case, it's asking us, are they going to converge or not? So basically, is our absolute value of r going to be less than 1? So if you want to, pause this video for a second, try these problems, and then turn the video back on and check your answers. Take a second through your answers here and compare. I'll go through number 1 with you. I found that it's geometric with a ratio of being 2, so therefore it would not be a converging series because r is not less than 1. And then I'll let you check numbers 1 through 5. So what I'd like for you to do now, this keeps jumping around. We're going to write the equation of the sum of the infinite geometric series. So since this is an infinite series sum, it's just going to be s. It's not going to be s sub n because it's not partial anymore. So it's going to be s equals a sub 1 over 1 minus r when r is less than 1. So the only time you use this equation is when this is satisfied, and it only works for a geometric sequence or series, not arithmetic. So if you do not have a converging infinite geometric series, that means you can only find the partial sum of your geometric series. So that's what we're going to do in these next 3 examples. It says find the sum of each series, so it doesn't say arithmetic or geometric, so I have to determine that first. And then it says, or state the sum that does not exist and explain why. So basically, we're going to decide, geometric or not, what's the ratio, is it infinite, If it is infinite, we're going to find that infinite sum. And if it's not, we're going to explain that we can't find an infinite sum, but that we can find a partial. Okay, so if you want to, take a second, pause the video, try these on your own, and then come back and compare. If we go through these examples, you'll find that number 1 is geometric by dividing out to find our ratio of -1/2. That means this converges, so I can find an infinite sum. So I'm going to plug into the equation, take my a1 of -6 over 1 minus my r, so that turns to a positive, so it's -6 over 1.5. So that means that this series is going to converge to -4, meaning that the larger the n number, the answer is just going to keep approaching -4. If you check number 2 is also geometric. You'll find the ratio to be 1/3. That means this one also converges. So if I look at my sum, I plugged in my a1 of 3/4 over 1 minus 1/3. I changed that to 3 over 3 to get 2/3 in the denominator. I turned this into a multiplication problem, and I got the sum is approaching 9/8. So again, the larger the n value, the sums will continue to approach the value of 9 over 8. Lastly, if you look at number 3, we find that it is geometric. It has a ratio of the square root of 3, which in rational form is 3 to the 1/2 power. This does not converge, meaning there is no infinite sum since the absolute value of r is not less than 1. This means, like I said, there's no infinite sum, but you could find a partial sum if you were asked. So if I asked you to find the sum of the first 3 numbers of the series, we could find that. But there is no infinite sum for this series because that r value does not satisfy being less than 1. So that's it for notes today. Your homework and what you're working on tonight is page 1052. You are doing numbers 37, 43 odd, and numbers 101 to 108 all. You'll notice that we did change the homework check. I sent a reminder out last night. It will be tomorrow. It will still consist of the sums worksheet and the 2 assignments on page 1051. This homework assignment for tonight will not be on the homework check tomorrow, but this is what you need to be focused on and working on in class today. Hopefully you guys have a great day, and I'll see you tomorrow.